Okay, good afternoon. In previous lecture, we have studied about ideal machine, efficiency, maximum efficiency. Now, we have discussed about reversible machine. Okay, reversible machines means what? A machine having capacity or capability to do the work even in a reverse direction after removal of effort. Then machine is called as reversible machine. Another definition is the machine having efficiency is more than 50%. That time the machine is known as a reversible machine. Okay, the machine is capable of doing some work in the reverse direction, even the removal of effort. When we remove the effort, the machine get back in reverse direction. That is, the machine do the work in reverse direction also. That time the machine is known as reversible machine. That time the machine having the efficiency more than 50%. The example of reversible machines is a simple axle and wheel, then simple screw jack, single purchase crank, double purchase crank, etc. These machines are reversible machine. Okay, then irreversible machine, it is also called as non-reversible and self-locking machine. The difference is that reversible and irreversible, this machine is not capable to do the work in reverse direction when remove the effort of the effort. That is, when we remove the effort, the machine cannot do the work in reverse direction. The example of that machine is simple screw jack machine, and that machine having efficiency is less than 50%. That time the machine is called as irreversible machine. Okay, irreversible machine is not capable to do the work in reverse direction. Okay, then come towards the friction in machines. Okay, machine means there is a friction because of number of parts of them. When number of parts, there is movement in that parts, and that why the friction is developed. Okay, friction is developed, then we know about effort loss in friction and load loss in friction. Effort loss in friction means actual effort. It is the subtraction of actual effort minus ideal effort. Actual efforts means the effort in a regular machine, that is actual effort, and ideal effort means the effort in ideal machine. Okay, the actual machine is more than the ideal machine. Therefore, it is effort loss in friction is calculated actual effort minus ideal effort. Pf is equal to P minus Pi. That is, Pi is equal to W upon Vr. That is velocity ratio. In previous slide, we have discussed about Pi. Okay, P means actual effort and Pi means the ideal effort. Then load loss in friction. There is a loss of load due to friction, and it is calculated ideal load minus actual load. Ideal load means what? The load in ideal machine, and which is maximum than actual load. Actual load means the load in regular, when there is a friction, that time the load is there, it is an actual load, and it is always less than ideal load. Hence, load loss in friction is calculated by ideal load minus actual load. That is Wi minus W. Wi is calculated P into Vr. In previous slide, we have seen about Wi, that Vr is the velocity ratio and W is the load. Okay, there are some standard graphs in simple lifting machines. First graph is load versus effort. This graph shows the load on x-axis and effort on y-axis. then if we draw the graph we get such like the graph is started from this point, and this is a C, that is machine friction or the effort required to start the machine. Okay, next, this is a graph between load and percentage of efficiency. Okay, if we draw or if we take the load on x-axis and efficiency on y-axis, then we draw the graph in freehand curve, then we get that type of curve. This is a load and percentage efficiency graph. This is the standard graph. Third is load versus mechanical advantage. Here, in load is constant, only on y-axis the curve is variable. That is, on x-axis load, on y-axis here mechanical advantage, and graph is become like this. It is a maximum mechanical advantage and it is a 1/m. This graph between load versus ideal effort. If we take load on x-axis and ideal effort on y-axis, then we get the graph like that. This graph or this line starts from the origin. This graph between load versus effort loss in friction. If we take load on x-axis and effort loss in friction on y-axis, then we get the graph like that. Okay. Then some simple machines are there. Study of some simple machines. First machine is simple wheel and axle. Okay. This is a effort wheel. This is a load wheel or load axle. Here the rope are there mounted on this axle and effort wheel. This rope contains at the bottom effort is there, and this axle, the rope is mounted, and at the bottom of the rope there is a load. Load having maximum weight and effort having minimum weight. By using minimum weight or minimum effort, we can lift the maximum load due to this mechanism. This mechanism is a simple wheel and axle machine. Okay. Velocity ratio, value of velocity ratio for different simple machines are variable. For simple and axle wheel or simple wheel and axle, the velocity ratio is distance traveled by the effort to the distance traveled by the load. For this machine, it is pi d, that is distance traveled by the effort is pi d, and distance traveled by the load is pi into small d. Okay, by cancelling pi, we get velocity ratio is capital D divided by small d. Capital D means the diameter of the effort, and small d means the diameter of the load curve. Please, first, that is capital D, that is diameter of this effort wheel, and small d means the diameter of this load drum. Second, okay. Second machine is differential axle and wheel. Okay. The function of all machines are same. That is, using minimum amount of effort, using minimum amount of effort, lift maximum amount of load. So only the mechanisms are different. Slightly mechanisms are different. Here, two axle. Bigger axle and smaller axle are present, and here effort will be. Next, velocity ratio for differential and axle wheel is calculated, that is distance traveled by effort to the distance traveled by load is pi d. Distance traveled by effort is equal to pi d, and distance traveled by the load is equal to pi by 2 into d1 minus dt. By cancelling, we get velocity ratio 2d upon small d1 minus dt, where d means diameter of the effort wheel, small d1 is equal to diameter of the larger axle, and d2 means diameter of the smaller axle. Next machine is simple screw jack machine. This machine is a non-reversible example of non-reversible machine. Okay, here a handle is provided of length L. Instead of handle, there is a effort wheel also provided. Here pitch are screw. This is a one type of screw, and it is a threads of screw. The distance between two threads is a P, that is pitch of the screw. Okay. Here effort is applied here and load is lifted here. Next, the velocity formula for velocity ratio of simple screw jack is distance traveled by the effort is pi and distance traveled by the load is P, that is pitch of the screw. If instead of effort wheel the length of handle is provided or length is provided, then formula is 2 pi L upon P, where L means length of handle and here D means the diameter of the effort wheel and P is the pitch of the pitch distance. Fourth machine is Weston's differential pulley block. Here the diagram of Weston's differential pulley block. Here effort is applied here, and by using small effort, the maximum amount of load is lifted. Okay. There are two differential pulleys are there. Here one pulley and here second pulley. Two differential pulleys, hence it is called as differential pulley block. Here bigger pulley and here a smaller pulley. Okay. Velocity formula of velocity ratio of the Weston differential pulley block are distance 2 pi r, that is distance traveled by effort, and distance traveled by load is calculated 2 pi r divided by t. Then we get final formula is velocity ratio is equal to rt divided by capital T, where r is the radius of the effort wheel and small r is the radius of the load drum. Next machine is worn and worn wheel. The mechanism of machine is like that. Here effort wheel, where effort is applied a small effort, and by using small effort we can lift maximum load. Here gear set is provided. Also here a gear set. As the machine is or effort is moved downward direction, it lifts the maximum load. These are two worms. This is the load drum. Okay. The formula for velocity ratio is distance travelled by the effort to the distance travelled by the load. Distance travelled by the effort is calculated by 2d and distance travelled by the load is calculated capital D minus small d. Capital D means diameter of the bigger pulley and small d is the diameter of the smaller pulley. If instead of pulleys their gears are provided, then formula become velocity ratio 2t1 divided by t1 minus t2. T1 means number of teeth on bigger gear and T2 means number of teeth on smaller gear. 6 number single gear crank or single purchase crank. Okay, here one set of gears are provided, hence it is called as single purchase crank. This is the pinion wheel or it is a spool wheel. This on pinion wheel and spool wheel there are number of teeth are provided here, and the energy is transmitted by this gear. When we apply the effort, this effort wheel is rotated. That's why this shaft rotated and also this gear rotate That's why this gear, that is main spool wheel, are rotated, and this rotate as the shaft or load drum is moved, and that's why load is lifted. Velocity ratio for single purchase graph: distance traveled by effort is pi d, and distance traveled by the load is n2 upon n1 into pi d. Then we get the formula, final formula: capital D into L1 divided by small d into N2, where L1 is number of teeth on spool wheel and N2 means number of teeth on pinion wheel. This is a double purchase craft. Next machine is a double purchase craft. It is also called as double gear craft or double purchase craft. Here two gear set are there, hence it is called as double purchase craft. The mechanism is like that, single purchase craft. The formula for velocity ratio for double purchase craft is capital D upon small d, N1 into N3 divided by N2 into N4, wherein N1 and N3 means number of teeth on spool wheel, and N2 and N4, that is number of teeth on pinion wheels. If handle is provided instead of effort wheel, then formula becomes 2L N1 into N3 divided by small d into N2 into N4. Then L means 2L, L means length of handle. And last motion is geared pulley block. Okay, there are two pulleys are there. Here load and here effort is applied. Here two gear sets are. One gear set is provided. Next, the formula for geared pulley block velocity ratio is N1 into N3 divided by N2 into N4. Velocity ratio is equal to N1 into N3 divided by N2 into N4. N1 means number of counts on effort wheel, N2 means number of teeth on pinion wheels, N3 means number of teeth on spool wheel, and N4 is number of counts on load wheel. If the effort wheel is another formula is, instead of N1 and N2, instead of pulleys, there is a handle, effort wheel is provided, then velocity ratio is equal to capital D into N3 divided by small d into N2, where D is the diameter of the effort wheel, small d is the diameter of load drum, N2 is number of teeth on pinion